Hi everyone, I hope you are doing good. So today in this series, in this video, we will take a new question here, which is recently asked in the interview. So first we will discuss the questions, then we will discuss the algorithm, and then we will implement that algorithm, whatever we will discuss into the C++ code, and then we will run the multiple use cases, right? So let's understand the question first. The question is given a grid of dimension n cross m, right? So we will get a n cross m basically matrix, and then that matrix will consist 0 and 1, right? So that matrix will have 0 and 1, and find the unit area of the largest region of ones, right? How many ones are connected to each other, that we have to find. A region of ones is a group of ones connected to 8 directionally, right? In all the 8 directions, if one is connected to one, then we will consider two basically, right? So let's understand this question with example here. So the example is the given is a grid. So I'm writing here grid one. So right. So now we have to find the maximum area, right? Maximum area which are basically connected by one and one, right? All the ones. So that we have to find maximum area, right? So largest area it is saying. So this is the given grid, and in this grid we have to find the largest region of ones basically, right? So the largest region is this one. This one is connected to this one, right? And this is the largest region. And how many ones are here? It is consist 5 ones. So our answer would be 5 here, right? So if we take another example here, so let's make this one to 0, right? This one we have made it 0. So now in this case, what would be your answer? So in this case, we have the largest region which consists all the ones is this one, 3, right? So this is the largest. We have this also, but this is 1, right? And this is having 3. So our answer would be 3, largest one, right? 3. So I hope you understood the questions. We have to find the largest region which is having all ones, and all these ones are connected to each other, right? Either horizontally, vertically, or diagonally. So these ones should be connected. So that will be considered as a one region, right? So that we have to find. So think about the solution, think about the algorithms approach, right? And then comment below the video. I'm also thinking, and I'll discuss my approach. What I'm thinking is, and if you have different than this one, then comment below the video, right? So let's start with my approach.
3, 2, 1, go.
Basically, this is similar algorithms to the last previous couple of videos, where we have the one I remember is where we have one questions to count the number of shapes. The matrix was having some X and O, right? X, we have to count the shapes of X, which consists X connected X basically, right? And in 4 directions, there we were checking vertically and horizontally only, right? And the other video we have already discussed is like finding the number of islands, right? And islands were consisting all the connected ones, right? Means land. One means land and zero means water there, right? And there we were checking in all the 8 directions. So I would recommend you to go and watch my those videos. If you already watched, then that is good, well and good. And this question would very easy for you. This algorithm will also be similar to those only. And if you have not gone through those videos, then please go and watch those, because those are very similar to this one, and those are very helpful while approaching or while solving these questions. If you know those approaches, then it would be very easy for you to understand. So let's start with this one. What I'm doing here. So first, what I will do, I will check each and every node, right? So for this, I have this algorithm here, this one. So I have here two loops, right? So because matrix, when we have to traverse the matrix, we use two loops here, right? One for row and one for the column here. And here, if we encounter one, in that case, we will increment the region count. So then we will start the calculating the area of the region, or the count of the ones in that region, right? So here one count is 0. We will pass this position, right? Here what we are doing, we are passing this position to this function here. The function is update all counted ones to 0, right? Here. And here we are passing grade, position, and the one count, whatever the one count we have, right? And here we will go to this function, and in this function what we are doing, we are checking all the 8 directions, and for the connected nodes here, connected ones, right? So what we are doing, we are starting from the first node here, right? And here what we are doing, we are passing this upgrade all connected 1 to 0, and here we are passing grade, position, and the one count, how many ones we have in this current region, right? So that is what we are doing here. And this is our base condition, because this is our recursive function, right? If we are either out of bound or we are having 0, in that case we will just return it, right? Otherwise we will update the we will basically upgrade like update the count here by 1, and we will mark it to 0, this current position to 0, right here. And then here we are checking this one is for I comma j plus 1, that would be right side, right? So it would be for right. Then the second call is for the basically right and down, right? So this would be right and down, and this call is having for the here I plus 1 means row plus 1, that is down only, right? This would be for down, right? And here this one is for the left and down, and this one is for the left, correct? Because j minus 1 we are decrementing the column only. And then the third one, this one is for basically uh, we are I minus 1, j minus 1 means up we are going, and we are going left side. So you can say up left, right? And then this one for the up only, right? I minus 1 we are decrementing the row only, column is same. So this is up, and then this one is for the basically right up. Right, so these all 8 directions we are considering, we are checking in all the 8 directions, right? So here these calls are making the call to the itself only, right? Recursive calls it is making. So here what we are doing, first like we are checking right side. So we have here one count, you can say one count is 1 here, right? And then we will make it to 0. We will make this to 0, and then we will go to the right side. We will check all 8 directions, and we found this one. So then again we will update this one. This is 2, right? And then we will check in all 8 directions for this position. We found this one here, and we are making to 0 them one once we visit this one. So this is 3 now, right? 3 once we encountered, and now for this one we will return back here, and we will come back to this function again, right? And we will check for the next position, this one, this is 0, so we will not do anything. See here I have added grid I comma j should be 1, then only we will go and recursively check all the 8 directions. If it is 0, then no need to check, right? It cannot be a region. So now till now we have maximum count is 3, right? And here then again if we found any 1, so for this one no 0 0 0, right? For this one we found 1 here again. So now we will go again, and here we are sending 0 only, 1 count, right? And here we are updating in the result. So in result we have 3, right? From the previous call, right, of 1. And here we go and check, and 1 all the surrounding ones is 0, so it will return 1 here. So this function will return here 1, and 1 is less than this, so we will not update our result, because we are looking for the maximum the largest region basically here, right? So that is what we are doing. And then again we are making it to 0, right? And then we go, this one is 0, this is 1. So now we will check the connected one, so this is 2, so we will make them 0, and the result we will get it 2 here from this function, recursive function, right? 2 is also less than this one, so our final result would be 3 here, right? So because we are taking care of the maximum here only. So I hope you understood this one. This is similar to the previous ones, right? That is why I am recommending you to go and watch those videos. Anyway, I have explained here where what I am doing. I am traversing through the complete matrix for each and every node, and I am checking all the connected nodes of that using the helper functions, and which is recursive function, right? So it can be done using the separate matrix also, where we can basically store the visited nodes and non-visited nodes. So that's all. So now let's have a look into the code. So this is the code I have implemented here. So see here we have a main function, right? Same main functions where we are taking the input from the user, and this is our functions where we are calculating the largest region here with ones, right? Yeah, so here these two loops we are using for iterating through the complete matrix, right? And here if we find 1, in that case we can consider this one as a region, right? And here we will start the counting the ones in this current region, right? And here one count we are passing, and we are taking, this is the IO parameter, means we are giving the input, and we are taking output also from here, right? And then once we check if this one count for this current region, right, it will go into this region, and it will find all the connected ones, right here, all the connected ones, and make them 0, and it will update the count here, one count, right? That is what it is doing in all the 8 directions. I have explained it, right? All the 8 direction it is going, and it is basically checking for the 1, right? And here we are updating the count, and here we are basically making the, once we have updated the count, we have visited that node, we are making that 1 to 0, so that it can not be visited next time, right? So that is what we are doing, and then once we are done with the current region, then we are returning, and here we are having the 1 count, right? How many ones we are there in in that region, right? So then if that one count in that region is the greater than the previous result, whatever we have the result, right? So then we will update this one, else we will ignore it, because here we are looking for the largest region which is having more number of ones than the previous ones or the other ones, right? That is what we are doing here. So let me build it one here. So here build is done, right? So let me run this one. So here it is asking for the use case count. So let me give three use case here. And then it is asking for the matrix size. So we will take the same example here, or you can see this one. This is the example we discussed, right? So this size is 3 comma 4, right? Here you can see 3 rows and 4 columns. That is why I am taking 3 comma 4 here, and then we will basically enter the elements here, matrix elements, right? So the matrix element is 1 comma 1 comma 1 comma 0, right? Then 0 comma 0 comma 1 comma 0, and then we have 0 comma 0 comma 0 comma 1, and here we are expecting 5, right? That is what we discussed, right? So because all these ones are connected to each other, right? These are connected horizontally, this is connected vertically, and this is connected this is diagonally, basically, right? So this is one region what we discussed, right? That is why we are getting 5 here. Now take the another example. So here also let's take same matrix, but we will make this row to 0 0 0, all 0. So here we will separate it out, basically. So here the size is 3 comma 4, correct, right? And then we will enter the element here, 1 comma 1 comma 1 comma 0, then I'll say 0 0 0, and then I'll say 0 0 0, and then 1. See here maximum we are getting 3. Why 3? Because this is the largest region, right? This is the largest region. This we have one more region here, but that is having only one value, right? One area is one only. So that is why I am saying no. Just consider this one. This is the largest one. So that is why I am returning the 3 here, maximum one. Now take another example here. So the same example, but first we will take the smaller one, and then we will have the larger region here. So for example, this is 3 comma 4, right? And here 0 1 0 0, right? This is having 4 column. Then again we can say 0 0 0 0, right? And again here we have this one, right? uh, 1, or 1, you can say 4. So here you can see 4, because this is the region which is having maximum number of ones, right? This is the another region, but it is having only one value here. This area, the area of this region is 1, and here area of this region is 4. That is why we are getting 4 here. So I hope you understood the question, you understood the algorithms, whatever we discussed with multiple use cases. We did the dry run also, right? And then I have run I have explained you the code, C++ implementation of this algorithm, and there we have run the multiple use cases, right? So yeah, that's all from my side. So see you next time. Till then, keep learning and keep exploring.